Right, this is a bit of a pig question. They've just purposely tried to make it awkward. Okay, so we've got two stages here. We've got the spring when it's partly stretched, okay, and because the spring is partly stretched, it's going to have a certain amount of energy stored in it. Okay, it's that amount of energy. And now, because we know the spring constant, we can work out how much it's been extended based on that energy. Now, we know this is to do with a spring, and we know it's talking about energy, so we know we're going to have to use the elastic potential energy equation. So C, F, I, F, A. Because we know it's a spring, that's always going to be elastic, and we know we're talking about energy because it simply talks about energy now. So we find the elastic potential energy equation, which is there, that one, which is E equals half the spring constant times by extension squared. Now, we have a quick look through here, and there's absolutely no need to do any converting. So we've got E equals half the spring constant times by extension squared. Now, let's put our numbers in that we know. Okay, so all I'm going to do is I'm going to put that as a full number. So 0.45, then 0.045. Okay, so we know that it's 0.045, so we don't have to be messing around with standard form. Okay, equals half of the spring constant, which is 200. Okay, and then where are we? We want the extension squared, which is what we're trying to work out. Okay, so what we then do is we're going to have to rearrange it for extension squared. So we need to divide by the 200 to get extension squared on its own. We do exactly the same there. 200, those cancel. So what we end up with is 0.045 divided by 200. That gives us our extension squared. Okay, so if we do that on the calculator, 0.045, oops, fraction button because we're dividing, 0.045 divided by 200, because that's half our spring constant, that gives us that number, 2.25 times 10 to the minus 4. Okay, so we can do 2.25 times 10 to the minus 4, but that is the extension squared, so we need to square root that. Okay, so what we do is we get that 2.25 times by 10 to the minus 4 gives us that. Okay, so we've got 0.015 meters of extension, but that is only the extension of the spring before they add the weight on it. Okay, so that's how much they start with. So that's our first bit. Now they add a weight to it, so we need to work out how much the extension increases from that. Now, if they're adding a weight, what we need is an equation that's talking about springs and extension that has force in it, because force is measured in newtons. So we see phi for it again, and we find an equation that's about springs and spring constant that's got force rather than energy in it. Now remember, force stuff's always going to be on the back, the paper 2 stuff. So we go down and we look for things with spring constant in. Okay, and then we can see it's got spring constant, it's got force, it's got extension. Okay, so it's F equals K times E. There's no converting, so we write F equals K times E. We put our numbers in. Our force is 2. Our spring constant is 400. Remember, we don't need to halve it this time, it's just that, times by E. And it's not a squared, it's just an E. So what we do now is we rearrange. So what we can do is 2 equals 400 times E. We want to get E on its own, so we divide by 400. Whatever we do to the right, we do to the left. So 2 divided by 400. That cancels that. So what we end up with is 2 divided by 400 equals E. So 2 divided by 400 equals our answer. Okay, so we do 2 divided by 400 equals that. 5 times 10 to the minus 3. Okay, so we divide it by, because it's minus 3, it's going to be 0.5, then it's going to be 0.05, and then it's going to be 0.005. So our answer is 0.005 meters. Okay, now all we need to do now is, that's the original extension, because remember the spring had energy in it at the start, so it must have been extended a little bit because it's had that amount of energy in. Okay, and then they added a weight onto it, so it must have extended a bit more, had a bit more energy into it, and that's how much energy was added. So we just want the total, that's how much extension was added, sorry. So we just want the total extension. So we do 0.015, okay, plus 0.005, and that will give us 0.020. Okay, now just double check that on the calculator because we don't want to be messing things up. So 0.015 plus 0.005 gives us 0.02, okay, or 0.020. Okay, and that's our answer, 0.02. Lovely.